Very good afternoon, my dear students. Actually, I have discussed the basic properties of entropy as well as the average information in the last class. So actually, I told you that the entropy is defined as the average information content generated by discrete memoryless source. And already we derived all these things. And also you can write entropy as the ratio of average information content to that of total number of messages. So like that, once you do all these things, you will get the expression as minus summation j is equal to 1 to m p suffix j log p suffix j base 2. So the units of entropy are bits per the corresponding source elements. Okay. So already I told you the properties of entropy. I told you that the first as a first property. So whenever a data stream consists of single message with maximum probability p1 is equal to 1, then the entropy is 0. So you can get by substituting the values of the probability in the expression of entropy, because only one message is there, 1 log 1, so it will be 0. Okay. And similarly, in the as a second property, if a data stream consists of multiple messages, but out of them, please mute yourself. Case 7, kindly mute yourself. So whenever a data stream consists of multiple messages, and out of all the multiple messages, if only one message has maximum probability, which is equal to 1, and all other message probabilities are 0, then we can say that the entropy is also 0. Because if you substitute here, this will be minus 1 log 1 base 2, minus 0 log 0 base 2, minus 0 log 0 base 2, like that. Only one probability is maximum. So our entropy will be 0. And similarly, as a third property, I stated you that entropy of a particular event is always greater than or equal to 0. Okay, so therefore the minimum entropy of the event is equal to 0. Okay, so similarly, as a fourth property, the entropy for two messages. So a symbol, whenever a symbol consists of two messages, m1, m2, with their respective probabilities as p1, p2, then you can get the entropy as h is minus p1 log p1 base 2 minus p2 log p2 base 2. But we know that p1 plus p2 is always 1. So when p1 is p, then p2 will be 1 minus p. Okay, so please replace the value of p1 and p2 in terms of a single probability p. Okay, now upon substituting these values in the expression, we will get h as, that is the entropy as, minus p log p base 2 minus 1 minus p log 1 minus p base 2. Here I took minus as common from these two terms. Okay, and also I told you that the maximum entropy of the event with two equally likely messages is 1, and that occurs at p is equal to 1 by 2. See, this one you can get by representing as log m base 2. So here m is the number of equally likely messages are 2. So that's why log 2 base 2 you will get, and that occurs at p is equal to 1 by 2. Okay. And similarly, you can observe the property of m equally likely messages, m1, m2, m3 up to so on mm, with probabilities p1, p2 up to so on pm. This occurs at p is equal to 1 by m. So maximum entropy for m equally likely messages that occurs at p is equal to 1 by m is h max is log m base 2 bits per message. Okay. So similarly, if you have three equally likely messages, maximum entropy occurs at p is equal to 1 by 3 and h max is log 3 base 2. So similarly, if we have 5 equally likely messages, h max will be log 5 base 2, and this occurs at p is equal to 1 by 5. Okay. So like that we have completed all the properties. Sorry. So Hmax will be log m base 2 bits per message. Okay. So similarly, we took an example of different two probability case. Okay, P1, P2 are given. If you observe the third case, it is completely equally likely condition. And this first case where P1 is 0.01 and P2 is 0.99, it is similar to second property. That is entropy will be nearer to 0, because even though we have multiple messages, if one message is nearer to 1, message probability is nearer to 1, and if other probability is nearer to 0, then our entropy will be nearer to 0. Okay, this is the second property. So like that we completed. Actually, this is this portion in the last class only we completed. Now let us go through the information rate. Already we discussed the information rate. The definition for that is the total number of bits or the average bits transmitted per second is generally defined as the information rate. And in terms of mathematical expression, we can define it as the product of the element frequency and entropy. So element frequency and entropy, source element frequency and entropy. Here if we have divided the source, information source as a samples, then here you can represent as sample frequency. So whatever may be the source element, it is source element frequency multiplied by entropy gives you the information rate. And the units of information rate are bits per second. Bits per second. Okay. And units of the frequency are per second. Actually, if the source elements are samples, it will be samples per second. And if the source elements are messages, then it will be messages per second. So like that, based on the source element per second. And the units of entropy are bits per the source element. Here the source element is sample. So bits per sample is the unit for entropy. Okay. So accordingly, you can get the information rate units as bits per second. Okay. So already I told you this example, in which I told you that here we have 6 possible outcomes: P1, P2, P3, P4, P5 and P6. 6 probabilities are there, and 6 possible outcomes. So here in the question, if you observe, here outcomes are the source elements. So for entropy, units will be bits per outcome and frequency will be outcome per second. Okay, so outcome rate will be outcome per second multiplied by entropy gives you the information rate R. So in this example, entropy units are bits per outcome, and the frequency units are outcomes per second. Okay, and information rate units are always bits per second, and it is a product of outcome rate and entropy. Okay, so just the respective probabilities will be given to you, and substitute in the expression of entropy as H is equal to minus summation j is equal to 1 to 6, because there are 6 outcomes. Pj log p suffix j base 2. So this will be, please accordingly substitute. So minus of 1 by 2 log 1 by 2 base 2 plus 1 by 4 log 1 by 4 base 2 plus up to so on 1 by 32 log 1 by 32 base 2. Okay, so like that we will calculate the entropy, and that entropy multiplied by outcome rate. So here it is given as 16 outcomes per second. Okay, so our information rate will be 30.912 bits per second. Actually, I think we completed these 2 problems in the last class. So Mali, same another example. So here a continuous signal is band limited to 5 kilohertz. So continuous signal bandwidth, its frequency is plus or minus FM. So here you can say that FM is 5 kilohertz, but the minimum sampling frequency is 2 FM. So 2 into 5, that will be 10 kilohertz. Okay, so that is the minimum like some minimum frequency, sampling frequency. Now the signal is quantized into 8 amplitude levels using pulse code modulation system, PCM system, with probabilities P1 is 0.25, P2 is 0.2. Like that you have given with P8 0.05. Okay, so here can you tell me what are the units of entropy? Bits per how many levels or how many source elements? 8 levels అని చెప్పి స్పెసిఫై చేశారు. సో యూనిట్స్ ఆఫ్ ఎంట్రోపీ విల్ బి బిట్స్ పర్ లెవెల్. బిట్స్ పర్ లెవెల్ హియర్ యూ కెన్ సీ 8 levels. సో అందుకని బిట్స్ పర్ లెవెల్ విల్ బి ద యూనిట్ ఆఫ్ ఎంట్రోపీ. సో వన్స్ అగైన్ యూ విల్ సబ్స్టిట్యూట్. సో minus summation j is 1 to 8 p suffix j log p suffix j base 2 bits per level. So substitute all the values. 0.25 log 0.25 base 2 plus 0.2 log 0.2 base 2 plus up to so on 0.05 log 0.05 base 2. Units are bits per level. Okay. So we'll solve, and already I told you that log 0.25 base 2 is, the simplification is log 0.25 divided by log 2. Okay, log 0.2 base 2 ante log 0.2 base 2 ante divided by log 2. So upon simplification you can see that log a base 2 is log a by log 2. Okay. Like that you will calculate the entropy and you will get it as 2.728 bits per second, bits per level. And what is the level rate actually? That is the frequency. So 2 into FM, levels per second. So that is 2 into 5k, so 10k multiplied by 2.728. So you will get 27.28 kilobits per second. Okay, so up to this we completed in the last class. Now let us move to the some of the important problems related to your examination based on the entropy and information rate, based on the expression of entropy and information rate. Okay, so here you can see the example. This example is like the application oriented one. Okay, this example is application oriented one. Please observe clearly. So consider a telegraph source having two symbols, dot and dash. So how many symbols are there? Two symbols. Because there are two symbols, you can check if for the entropy you can use the expression of property 4. In the property 4 I told you the expression of entropy for two elements or two messages or two symbols, that is minus of p log p plus 1 minus p log 1 minus p base 2. Okay, if you write p1 and p2 in terms of p, otherwise it will be p1 minus of p1 log p1 base 2 plus p2 log p2 base 2. If you write in terms of p, both in terms of p, then it is minus of p log p base 2 plus 1 minus p log 1 minus p base 2. This equation you can observe from the property 4. Okay, so consider a telegraph source having two symbols, dot and dash. The dot duration is 0.2 seconds and the dash duration is 3 times that of dot duration. So you have given with the relation of dot duration and dash duration, and the probability of the dot occurring is twice that of dash, and the time between the symbols is 0.2 seconds. So you may get a doubt why they have given the dot duration, like similarly dash duration space between the symbols. Endukani icharu? This whole thing is calculate in, like this is a hint in order to calculate the frequency. Okay, first you will calculate the symbol time and reciprocal of that symbol time will be the symbol frequency. So in order to calculate the symbol time, they have given the dot duration, dash duration and time between the symbols. Okay, and first you calculate the symbol time and reciprocal of that symbol time will be the symbol frequency. Calculate the information rate of the telegraph source. So meeku em chepparamma, calculate the information rate of the telegraph source. I think you can recollect the expression of information rate, capital R, as the product of symbol frequency and entropy. Symbol frequency you can obtain by using these hints. ఈ time hints ఇచ్చారు కదా, So take the inverse of that. So you will get the symbol frequency. The symbol frequency multiplied by entropy. So entropy ki already cheppan meeku enti, here you have two symbols kabatti you will make use of the property 4 of entropy to calculate the entropy. So multiply that entropy with the symbol frequency in order to get the information rate. So that is the question. And if you can observe the points here. So what are the given values to you? So dot duration is given as 0.2 seconds. How much? Dot duration is 0.2 seconds. Just I have mentioned the points given in the question. So dash duration is 3 times that of dot duration and chapter. Okay. So 3 times that of dot duration is 0.6 seconds because 3 into 0.2. So that is 0.6 seconds. Okay. So next P dot is, and chudandi ikkada, the probability of the dot occurring is twice that of the dash and chapter. So P dot is 2 into P dash. Okay. And space between the symbols is 0.2 seconds. Space between the symbols is 0.2 seconds. So you are supposed to calculate the information rate. So in order to calculate the information rate, you need symbol frequency and entropy H. Okay. So probabilities of dots and dashes. So in order to get the entropy, first you need to calculate the probability of dot and probability of dash. You are given only the relation. Okay, you are only given with the relation between P dot and P dash, but you are not given with the values. So meer ippudu values calculate cheyali. So let the probability of the dash be P. So edo okati assume cheskondi because P dot is given as twice that of P dash. So please assume the probability of dash as some P. So then probability of occurrence of dot will be 2 into P dash. So 2 into P avutundi. But you know, we all of us know that total probability due to all symbols in an event is 1. The total probability of all the element occurrences is 1. So P dot plus P dash is 1. But P dot is how much? Twice that of P. So 2P dash plus P dash is 1. Okay. So P dash will be 1 by 3. So wherever P dash is 1 by 3, our P dot will be 2 by 3. So finally we obtained the probability of dash and probability of dot. So two symbols ki probabilities vachesai. So next, once you know the probabilities, what is the next thing? You need to calculate the entropy capital H. So let us calculate the entropy capital H. What are the units? The units are bits per the source element. Here the source elements are two symbols. So bits per symbol will be the unit of entropy. So H of x is minus of P dot into log P dot base 2 plus P dash log P dash base 2. Two elements unnai kabatti P1 log P1 base 2 plus P2 log P2 base 2. Here P1 is P dot and P2 is P dash. Now already you know the probability of P dot. We obtained it as 2 by 3. And we obtained the probability of dash as 1 by 3. So 2 by 3 log 2 by 3 base 2 plus 1 by 3 log 1 by 3 base 2. One more thing is, while calculating log 2 by 3 base 2, you should solve as log 2 by 3 divided by log 2. Log 2 by 3 divided by log 2. And similarly log 1 by 3 divided by log 2. I request all the other students, meanwhile, please go through the problem. Just you simplify this, log 2 by 3 divided by log 2. I told you to please keep your calculators beside you. In the last class only I informed you. Please take your calculators and solve this and check whether the answer is right or not. Because in the examinations you have to do on your own. So like simplification you need to do clearly. So log 2 by 3 divided by log 2. Alane ikkada log 1 by 3 divided by log 2 into 1 by 3 vestaru. So simplify this and check whether it is equal to 0.1982 bits per symbol or not. అది మీరు చెక్ చేస్తూ ఉండండి simultaneous గా. So next here we have obtained the entropy as H as 0.9182 bits per symbol. Next, okay, finally we obtained the probabilities in the first bit and second step lo manaki em calculate chesaru, average information calculate chesaru. Next, symbol rate. What is symbol rate? Symbol rate is a reciprocal of symbol duration. Symbol rate is the reciprocal of symbol duration. But in the question you are given with the time interval of dot, time interval of dash. Okay, and spacing between the two successive symbols. So spacing between two successive symbols. The symbols may be either dots or dashes. So spacing between the two symbols ent ichchadu manaki 0.2 seconds ichcharu. So what is the symbol time? Symbol time. Let us calculate the total symbol time, which is equal to the occurrence of dot plus the dash occurrence duration plus spacing. Okay, but T dot, that is dot duration, will occur only for the probability of P dot. Okay, so T dot into P dot pettukuntaru plus our dash symbol will occur for a probability of P dash. So T dash multiplied by P dash plus the spacing between the dot and dash. Okay, here T space represents the spacing between two successive symbols. The symbols may be two dots or two dashes or dot and dash. So whatever may be the symbol, spacing is generally used to eliminate the inter-symbol interference. Okay, so generally some spacing should be provided between two successive symbols to overcome the problem of ISI, capital ISI, acronym ISI. It represents the inter-symbol interference. Okay, so T dot is 0.2 multiplied by P dot is 2 by 3 because probability of dot we obtained as 2 by 3 and plus T dash is 0.6 multiplied by P dash. What is P dash? What is P dash? Probability of occurrence of dash for a duration of 0.6 seconds multiplied by 1 by 3 plus T space is 0.2. So finally we obtained the total symbol time as 0.5333 seconds per symbol. Okay, this is the symbol time. Okay, seconds. This is per symbol. For symbol, this is a symbol duration. But our symbol rate will be the reciprocal of symbol duration. So 1 by Ts, it is 1.875 symbols per second. So R is 1.875 symbols per second. So information rate capital R is, so finally you obtain the symbol frequency, entropy kuda vachesai. So what next? You need to calculate the information rate. So information rate is the product of symbol rate and entropy. Symbol rate is 1.875 multiplied by entropy is 0.912 bits per symbol. So upon multiplying, you will get it as 1.72 bits per second. So this is how you need to solve this problem. This problem is very, very important for your final examination. So almost 6 to 7 times these problems have repeated for your seniors. Okay, so this is an application oriented problem. So sometimes they won't change the values. So directly they will give the same values. So it's better to be thorough with these kind of problems, application oriented problems. Okay, and this is also important question. Okay, so a message source generates, please wait. So is this answer okay? 1.72 bits per second. So did any one of you solve? If answer is right, please say yes from your side. Did any one of you cross verify this? Chesarma everena? Any one of you? Did any one of you solve this problem? If so, please say yes, so that we can proceed to the next problem. Did you check the answer or not? If so, please say yes. Any one of you. So almost 44 students are there. C2. C2. Check చేశారు మా ప్రాబ్లమ్ లాస్ట్ ప్రాబ్లమ్. Is it okay? Answers correct అయినా వచ్చాయా? కరెక్ట్గా వచ్చాయా? Okay ma, thank you. You can mute yourself. Now let us move to the next problem. So here a message source generates one of 4 messages randomly every microsecond. So every microsecond 4 messages are randomly generated. So that may not be in order but randomly generated. So every microsecond. Okay, so 10 power minus 6 second. Okay, so that is the time duration. So the probabilities of these messages are 0.4, 0.3, 0.2 and 0.1. So you can add all this so that the sum of all this should be equal to 1. Okay. Each emitted message is independent of other messages in the sequence. Okay, each emitted message is independent of other messages in the sequence. So what is source entropy and what is the information rate generated by this in bits per second? So you need to calculate the source entropy and information rate. Here this statement, each emitted message is independent of other messages in the sequence. This is the property of information. So generated messages are independent to each other. Okay, so let us solve the problem in order to calculate the entropy and then information rate. So we are given with 4 probabilities. So use those 4 probabilities to calculate the entropy capital H as minus of P1 log P1 base 2 plus P2 log P2 base 2 plus P3 log P3 base 2 plus P4 log P4 base 2. And given capital M is 4. Okay, and one message is transmitted per microsecond. So what is the message transmission rate? Reciprocal of the time interval. So it will be 10 power 6 messages per second. So what is the frequency? Frequency of source element message? 10 power 6 messages per second. So you can write it as message transmission rate or message frequency. Now let us calculate the entropy capital H. So in order to obtain the source entropy capital H, it is equal to minus summation j is equal to 1 to m p suffix j log p suffix j base 2. Here m is how much? 4. 4 messages unnai kabatti 4. So that's why it will be minus of 4 messages ki manam source entropy expression rasaru. So it is equal to minus 0.4 log 0.4 base 2 plus 0.3 log 0.3 base 2 plus 0.2 log 0.2 base 2 plus 0.1 log 0.1 base 2. See, already I told you one point that here in the denominator you have log 2 వస్తుంది. ఎందుకని log 0.4 divided by log 2 వస్తుందమ్మా. So you can take minus 1 by log 2 as common from this whole summation. Summation series nunchi you can take 1 by log 2 as common. So that it will be 0.4 log 0.4, 0.3 log 0.3 plus 0.2 log 0.2. అప్పుడు బేస్ 10 కి క్యాలిక్యులేట్ చేసేయచ్చు. సో 0.1 log 0.1. So finally you will get the entropy as 1.846 bits per message. So already I told you that even though we have negative sign in the expression of entropy, you won't get entropy as negative. So entropy is from the third property. Entropy of an event h of e is always greater than or equal to 0. It is 0 only for 2 properties. First property enti, if message only one message undi and if that message probability is 1, then your entropy is 0. And even you have multiple messages, if one message probability is 1 and all other are 0, In that condition, you will get entropy as 0. So, but in all other cases, it is always greater than or equal to 0. Okay, so finally you obtained H as 1.846 bits per message. So how can you get the information rate capital R? It is small r into H, that is message transmission rate multiplied by entropy. So message transmission rate is reciprocal of that message interval. So that is 10 power 6 into 1.846. So 1.846 megabits per second. So this is the information rate. So this is how you need to solve the model of problems. And this is also very important question, like the third problem. Okay, so high resolution black and white TV consists of 2 into 10 power 6 picture elements. So black and white TV picture consists of 2 into 10 power 6 picture elements and 16 different brightness levels. Pictures are repeated at a rate of 32 per second. All picture elements are assumed to be independent and all have equally likelihood of occurrence. Calculate the average information rate conveyed by this TV picture source. Okay, so here they have in the question they have given you one hint. Entamadi, all picture elements are assumed to be independent. So anni kuda independent ani cheptunnaru. That is a generalized fact, and all levels have equally likelihood of occurrence. So how many levels are there? 16 levels are there. So capital M is 16. So probability of, so whenever all these probabilities of the different levels are equal, then you will get maximum entropy H max at any one of you. So here you have given 16 different brightness levels, and they are telling you that all these are equally likely. So once all the probabilities of all the levels are equally likely, then the maximum entropy occurs at log m base 2. That is the sixth property of entropy, log m base 2 at p is equal to 1 by capital M, where m is 16 in this case. Okay, so maximum entropy H is equal to log m base 2, which is equal to log 16 base 2. So it is 4 log 16, you can write it as 2 power 4. So 4 you can take outside the logarithm. So log 2 base 2 is 1. So log 2 base 2 is 1. Okay. So here you can see that 4, so that's why you will get 4 bits per picture elements. Now finally you obtain the entropy as log m base 2. Okay, good. But what about the element rate? What about the element rate? It is given as 2 into 10 power, because here you can observe the black and white TV picture consists of 2 into 10 power 6 picture elements and 16 different brightness levels. These are repeated at a rate of 32 per second. So picture elements are 2 into 10 power 6 and its rate is 32 per second. So 2 into 10 power 6 multiplied by 32 per second. So it will be 64 into 10 mega picture elements per second. Okay. So information rate R is small r into H, that is the element rate multiplied by entropy. So 6 mega multiplied by 4. So you will get 256 megabits per second. So this is how you need to solve. You need to calculate the element rate. So picture elements are 2 into 10 power 6 picture elements. Its frequency is 32 per second. So you will get 64 multiplied by 10 power 6 picture elements per second. Okay. Next, and this is also very important problem for your examination. See, these model of problems directly you will get, so without changing any of the values. Okay. So 6th is, in a fast mail transmission of picture, there are about 2.25 into 10 power 6 picture elements per frame. So So this many picture elements are there. For good reproduction, 12 brightness levels are necessary. For good reproduction, 12 brightness levels are necessary. So levels are 12. So capital M will be 12. Okay. Assuming all these levels to be equiprobable. So equiprobable annaru ante ventane meeku teliyalsindi enti, at p is equal to 1 by m, that is at p is equal to 1 by 12, you will get maximum entropy at log m base 2. So entropy meeku ichesinatte. So whenever you in the question, if you got a hint like all these probabilities are equally likely anna, ledante all these levels are equiprobable anna, then you should know that the probabilities of all the levels are equal. Then you can say that maximum entropy is log m base 2, and that occurs at p is equal to 1 by capital M, that is 1 by 12. So H max is log m base 2 and m ఎంత ఇచ్చారు 12. So based on that, please substitute the value of m to get the maximum entropy. And number of pictures per minute is 1 by 3. So if you observe, to transmit, so calculate the channel bandwidth required to transmit one picture in every 3 minutes for a SNR of 30 dB. If SNR requirement increases to 40 dB, calculate the new bandwidth. Explain the trade-off between SNR and bandwidth by comparing these results. Actually, up to this point, ekkada varaku, so meeku calculation of entropy up to this point and calculation of information rate, this comes under module 2 or 3. This is a problem related to module 2 or 3. But here you need to calculate the relation between the SNR and bandwidth. This is based on the Shannon-Hartley theorem. That is like part 2 of chapter 4. Okay, part B of chapter 4. Anyhow, just you need to remember one expression. Based on that, you can solve this problem. So you are given with SNR of 30 dB and increase in the SNR is 40 dB. So then you need to calculate the change in the bandwidth. Okay, and you are also given with the number of pictures per minute is 1 by 3. Okay, please remember this. And picture elements per frame is 2.25 into 10 power 6 per second actually unit, but per minute it is given as 1 by 3. So per second kavali ante manaki enti avutundi 1 by 3 into 60. Okay. Please convert that minutes into seconds. So based on 1 minute is like 60 seconds, you can replace that and you can calculate the frequency rate. Okay, so let us first calculate the information rate. This is what as usual procedure. First, the number of picture elements per frame is 2.25 into 10 power 6, and these elements can be of any brightness out of possible 12 brightness levels. So capital M is 12. And they are given, you are given with all these are equiprobable. And from the definition, you know that information rate is product of message rate and entropy. And what is message rate? So the picture elements element rate is 2.25 into 10 power 6, which is like repeated per every 3 minutes. So per 3 minutes, but convert that minutes into seconds. So 2.25 multiplied by 10 power 6 divided by 180 seconds. So it will be 12,500 elements per second. That is your element rate. Okay. Next, here entropy. Already I told you that these 12 levels are equiprobable. So our entropy will be log m base 2. So that is log 12 base 2. So R will be how much? 12,500 elements per second multiplied by log 12 base 2 bits per elements. Because the units of entropy are bits per the corresponding element. Here the source elements are elements only. So that's why bits per elements. So 44.812 kilobits per second. Like that, first we'll calculate the information rate. And this is the first bit. Next, they asked you to calculate the bandwidth. Okay, actually this bandwidth and SNR relation is provided by, for an analog channel, is provided by Shannon-Hartley. So that is the Shannon-Hartley theorem or Shannon's capacity theorem, and it states that the information rate capital R is always less than or equal to the channel capacity. So until and unless our information rate is less than the channel capacity, so if our information rate crosses the channel capacity, will that channel has a capability to allow all our information? No. So that's why Shannon's theorem states that the information rate, what is the Shannon's theorem? Here you can observe that equation. Shannon's theorem states that the information rate capital R is always less than or equal to the channel capacity. What is the capacity of the channel? Okay. So we cannot feed you much more than how much you fill into your stomach. So like that, the channel has a capacity to allow only certain portion. Okay. So our information rate should be always less than or equal to the channel capacity. So where C is equal to bandwidth log 1 plus SNR base 2. Okay. This SNR represents the signal to noise ratio at the receiver section. So this equation is valid only when R is less than or equal to C. Okay. So channel capacity C is bandwidth into log 1 plus SNR base 2. This is the Shannon-Hartley theorem, and this is valid when R is less than or equal to C. Okay. So SNR in dB is 30 decibels. What is your SNR? Given SNR 30 dB. Now actually your SNR is given in decibels. Now please convert that into a normal value so that you can substitute directly in the expression of channel capacity. So your SNR here actually it is given in decibels, but in this equation there is so direct value you need to substitute. So instead of in decibels you get the normal SNR value. So SNR is, what is the expression for SNR in dB? 10 log SNR base 10. Okay, so make use of this expression and get the normal value of SNR. So it is 10 power SNR dB divided by 10. So 10 power SNR in dB is 30. So 30 by 10, it will be 3. So 10 cube. So it will be 1000. Okay. So whenever SNR in dB is 30 dB, a normal SNR will be 10 cube. So that is 1000. For example, if SNR in dB is 20 dB, normal value of SNR will be 100. So alane ikkada 40 dB annaru kabatti 10 power 4 ante 10,000 vastundi. Okay, so you are given with SNR in dB, get the normal value of SNR, you will get it as 10 power 30 by 10. So it will be 10 cube, so 1000. Okay, please substitute it in the expression. So you will get C is equal, C actually it is given. Is it given actually? No, we have calculated the information rate. So that information rate is always less than or equal to C, but actually we need C. So C is greater than or equal to R. Okay, so our value, so C is 44.812 into 10 cube. It is less than or equal to, this is our channel capacity. So bandwidth into log 1 plus 1000 base 2. So this left hand side represents R. R is less than or equal to C. Channel capacity is bandwidth log 1 plus SNR base 2. So our bandwidth will be greater than or equal to, please simplify this. This is log 1000 by log 2. Simplify this and you will get it as bandwidth is greater than or equal to 4.4959 kilohertz. Similarly, you are given with another SNR, increase in the SNR as 40 dB. So whenever SNR is 40 dB, in normal value of SNR will be 10,000. So in the same manner, please calculate the change in the increase in the bandwidth. Because R is as usual, information rate is 44.812 into 10 cube. R is less than or equal to channel capacity. C is bandwidth into log 1 plus 10,000 base 2. So your bandwidth will be 3.372 kilohertz. So trade-off between bandwidth and SNR. As the SNR increases from 30 dB to 40 dB, what happens to our bandwidth? Bandwidth initially it is 4.49 kilohertz. It is reduced to 3.372 kilohertz. So as the SNR increases, our bandwidth will reduce. So there exists a trade-off between bandwidth and SNR as inverse relation. As SNR increases, our bandwidth will reduce. Okay. This problem is also important, but this problem is related to this Shannon-Hartley theorem. So I can say that this comes under part B. Part B nunchi ravachu ee problem. Okay. Okay. Almost all we completed the related problems regarding the information rate and general equation of entropy, not on different types of entropies. Okay, ma. This is all about first 3 modules. Now, because we have completed the first 3 modules, let us start the new concept of from chapter 4. Okay, those are the different kinds of entropies. The different kinds of entropies and the mutual information. These are the leftover concepts in the part A of unit 4. So if we complete this module, we can complete the first portion of chapter 4. Okay, but this is very important, and this module has very important derivations. Okay, this is easy. So please concentrate so that you can easily attempt from this. Okay, so equations anevi you should write down. So whenever class is going on, please write down that expressions. Okay, so make it as a habitude, because we are not conducting the physical classes. So because we are not conducting physical classes, even though it is an online class, you please write down the notes. So please follow some material so that so even though we provide PPT for you, please maintain some notes for each and every subject, so that it will be like a practice to you on varieties of concepts in each and every subject. Okay, so please maintain notes for each and every subject. So no one is there to check your notes, but you alone get it habituated, or make it as a habit to write the notes. That is for your purpose only. Okay. సో ఎవరో చూస్తారు, పేరెంట్స్ చూస్తారు, లేదంటే టీచర్ చెక్ చేయట్లేదు కదా అని చెప్పి అట్లా ఏం చేయకుండా మెయింటైన్ సమ్ నోట్స్ ఫర్ ఈచ్ అండ్ ఎవ్రీ సబ్జెక్ట్. ఈవెన్ దో ద టీచర్ ప్రొవైడ్స్ యూ మెటీరియల్, బట్ మెయింటైన్ నోట్స్, బికాస్ మీ హ్యాండ్ రైటింగ్తో మీకు ఉంటే ఇట్ విల్ బి కంఫర్టబుల్ ఫర్ యూ టు రీడ్. ఓకే, టీచర్ ఇచ్చారు లేదంటే మా ఫ్రెండ్ నోట్స్ పీడిఎఫ్ తీసుకున్నాను, ఇవన్నీ కూడా మీకు సపోర్ట్ చేయవు. ఖచ్చితంగా మీరు రాసుకుంటే ఇట్ విల్ బి ప్రాక్టీస్ ఫర్ యూ. ప్రాక్టీస్ అవుతుంది, నెక్స్ట్ టైం ఇంకొకసారి రివైజ్ చేసుకోగానే మీ నోట్స్ అనే ఫీలింగ్ కూడా ఉంటుంది మీకు. ఓకే, అండ్ కమింగ్ టు ద మాడ్యూల్ 4 ఇన్ ద 4th చాప్టర్, మార్జినల్, జాయింట్, కండిషనల్ ఎంట్రోపీస్ అండ్ మ్యూచువల్ ఇన్ఫర్మేషన్. Please see that these are the different types of entropies. Already మనం entropy definition చూసారు మీరు. You have seen the definition for entropy and the equation for entropy and its properties in the module 2. And also we defined the information rate. What is entropy? It is the average information conveyed by the discrete memoryless source is called as entropy. So there are various types of entropies: marginal entropy, joint entropy and conditional entropy. So based on the number of messages transmitted or number of source elements, we have joint entropy and conditional entropy. Marginal is based on the occurrences of events in a particular section only, but joint entropy or conditional entropy is a interrelationship on various kinds of marginal entropies or various kinds of sections. Here in this module, I took an example of the traditional communication system. Okay, so let us move to the marginal entropy. Okay, please listen carefully. So in the marginal entropy, please, I am telling you to consider the real life example of communication system. So in the real life example of any communication system, that may be analog, digital or optical or satellite, whatever may be the communication system, it consists of a transmitter section, alane oka receiver section untundi, and a channel. Okay, so these three sections are mandatory, whatever may be the form or the type of modulation, okay, or the model of signal, whatever may be the form of the signal, we have three sections, namely the transmitter section, channel and the receiver section. Now, here I am telling you to consider capital X as a transmitter section. Okay, events that occur for the transmitter section, please consider it as capital X. What is capital X? What is capital X? Capital X represents the events that occur in the transmitter section. How many events are there? Capital M events are there. Those range from x1, x2, x3 up to so on x suffix capital M. Please remember that while representing the entropy, marginal entropy, please represent as capital H sub H of capital X and represent cheyali. So మీరు ఇంతవరకు ఎంట్రోపీని ఎలా రిప్రజెంట్ చేశారు? క్యాపిటల్ హెచ్ అని రిప్రజెంట్ చేశారు. బట్ హియర్ ఎంట్రోపీ ఆఫ్ ఎ ట్రాన్స్మిటర్ సెక్షన్ క్యాపిటల్ ఎక్స్ ఈజ్ రిప్రజెంటెడ్ యాజ్ ద మార్జినల్ ఎంట్రోపీ హెచ్ ఆఫ్ ఎక్స్, దట్ ఈస్ క్యాపిటల్ హెచ్ ఆఫ్ క్యాపిటల్ ఎక్స్, వేర్ ద సెక్షన్ ఎక్స్ consists of capital M number of events, x small x1, small x2 up to so on small f x suffix capital M. For the subset small x suffix j, here I am considering j as a variable that represents capital M number of events for the transmitter section. So where j ranges from 1 to capital M, 1 to capital M. In the same manner, let us consider h of y as the marginal entropy, h of y as the marginal entropy for the events that occur for the receiver section. Okay, so what is h of y? H of y is the marginal entropy for the events that occur for the receiver section. So receiver section events are considered as capital Y. That consists of how many events? Sorry, y1, y2, y3, y4 up to so on y suffix capital N. What is N? Okay, sorry. Here h of y represents the marginal entropy for the subsets that occur for the receiver section capital Y, which is y1, y2 up to so on y suffix capital N, where N represents the number of events that occur for the receiver section. It is represented with a variable k. It is represented with a variable k, where k ranges from 1 to capital N, where k ranges from 1 to capital N. Okay, so here then you can define the marginal entropy h of x as, here h of x represents the marginal entropy of the events that occur for the transmitter section, as h of x is minus summation j is equal to 1 to m p of xj log p of xj base 2. Now what is the marginal entropy of the receiver? H of y is minus summation k is equal to 1 to n p of yk log p of yk base 2. Okay, these two are the marginal entropies of the transmitter section events capital X and receiver section events capital Y. Here we are considering the variable to represent the transmitter section events as small j. That ranges from 1 to capital M. So, అందుకని p of x suffix small j log p of x suffix small j base 2 అని represent చేశారు. Now, what is h of y? H of y represents the events that occur for the receiver section, that is minus summation k is the variable to represent the events of receiver section. So, k is equal to 1 to n p of yk log p of yk base 2. K represents the events that occurs for the receiver section. So, what is the upper limit of k? Capital N number of events are there. So, this is how we will represent the marginal entropy. So, marginal entropy represents the events that occur for a single section or a particular section. Okay. So, this is the definition for marginal entropy of transmitter section and receiver section. Transmitter section events are capital X and receiver section events are capital Y. Okay. Next, let us please wait here once. Okay, this is the marginal entropy of transmitter section and receiver section. Now, let us move to the joint entropy. So, what is joint entropy? Now, here I told you the events that occur for transmitter section as capital X and the events that occur for the receiver section as capital Y. Now, this joint entropy gives the combined relationship between the transmitter section and receiver section. Now, let us assume S1 as the signal space representation of the transmitter section. What is S1? Capital S suffix 1 represents the signal space of transmitter section capital X, which consists of how many events of X? J number of events, that is x1, x2 up to so on xm. For xj, j ranges to 1 to m, and let us assume S2 be the signal space representation for receiver section. What is S2? S2 be the signal space representation for receiver section capital Y, which is yk, where k ranges from 1 to n. So, S2 is the signal space representation of receiver section and S1 is the signal space representation of transmitter section. So, for the receiver section, y is equal to yk, k ranges from 1 to n. So, y1, y2, the events will be y1, y2 up to so on y suffix capital N. Okay. Now, S1 multiplied by S2, that is S1, S2 will be the signal space representation of combined event due to both transmitter data and receiver data, that is xy is equal to xy consists, see, please represent like this, capital X capital Y consists of how many events? Xj number of events and yk number of events from the receiver. Transmitter నుంచి ఎన్ని events ఉంటాయి? xj events. J ranges from 1 to n, 1 to m, and yk events where k ranges from 1 to n. Okay. So, what is the signal space representation or signal space representation of the combined event due to transmitter and receiver sections S1, S2? So, you can observe the signal space representations of transmitter as S1. You can see the figures shown below. S1, in the S1 signal space representation, you have how many events of X? Capital M number of events. So, x1, x2, x3 up to so on xj that continue up to x suffix capital M. And S2 is the signal space representation that consists of y1, y2 up to so on yk up to so on yn number of events are there. Okay. And S1, S2 represents the combined signal space representation due to the transmitter and receiver sections. Okay. Now, let us move to the equation for joint entropy. Now, already I told you the expressions for marginal entropies. So, marginal entropies, marginal entropy H of x is dependent on the marginal probability. So, what is P of xj? P of xj is the marginal probability of the transmitter section. P of yk is the marginal probability of the receiver section, consisting of k number of events, and transmitter consists of j number of events. So once you know the marginal probability of all the events in the transmitter section, you can calculate the marginal entropy of transmitter section. Alane, once you know the probability P of yk, you can calculate the marginal entropy of the receiver H of y. Okay, so marginal probabilities P of xj and P of yk are necessary to calculate the marginal entropies H of x and H of y. H of x, H of y are capital letters. Okay, now marginal entropies can be represented in terms of, chudandamma, marginal probabilities can be represented in terms of joint probability. So what is the representation of joint probability? P of xj comma yk. So joint probability P of xj comma yk due to both transmitter and receiver sections as please observe the relation between the marginal probabilities and joint probability. So what is joint probability representation? P of xj comma yk. What is joint probability expression? P of xj comma yk. And this P of xj comma yk can be represented as P of xj as P of xj is equal to summation k is equal to 1 to m 1 to n P of xj comma yk. In this joint probability matrix, if k is replaced as k is equal to 1 to n, you can get P of xj. Similarly, when j is equal to 1 to m for P of xj comma yk, xj can be replaced. So you can replace xj because summation j is equal to 1 to m, xj can be replaced. So P of xj comma yk. So you will get it as P of yk. So similarly, if you replace k is equal to 1 to n, if you replace k is equal to 1 to n, P of xj comma yk will be P of xj. Okay, so a marginal joint probability. So if you make use of joint probability and if you want marginal probability, these two expressions are very much important. So these two expressions gives the relation between the marginal probabilities P of xj, P of yk in terms of joint probability individually. So these two equations are important, and please remember, while simplifying the expressions, you need these two relations. So summation k is equal to 1 to n P of xj comma yk, you can replace as P of xj, and summation j is equal to 1 to m, you can replace xj ante meeku P of yk vastundi. Okay, now so these two relations are very much important, please remember this. Now P of x comma y, what is P of x comma y? It is a joint probability matrix. P of capital X comma capital Y represents the P of capital X comma capital Y represents the joint probability matrix, which is defined as, please remember, listen carefully. P of x comma y represents the joint probability matrix, which is defined as summation j is equal to 1 to m, summation k is equal to 1 to n, P of xj comma yk, okay, P of xj comma yk. So P of x comma y is represented as summation j is equal to 1 to m, summation k is equal to 1 to n. Considering all the elements of transmitter and receiver sections, you will get the total joint probability matrix. Okay, so it is defined as the product of P of xj and P of phi k, because whenever whenever the two transmitter section and receiver sections are completely independent to each other, P of xj comma yk can be replaced as the product of P of xj and P of yk. Okay, please remember that this first matrix represents the P of xj matrix. P of xj matrix. How many elements are there? X1, x2 up to so on xm. And in yk, how many elements are there? Y1, y2 up to so on yn elements are there. And please observe that P of xj matrix, P of xj matrix or P of x matrix is of size m by 1. So it has m number of rows and 1 column. And receiver section Y is a single row matrix, that is 1 by n. So multiple number of columns are there, n number of columns, but only single row. So here we have designed the transmitter section, because in the transmitter section, if you remember, like in the third chapter we discussed phase shift keying. In the mRA phase shift keying, if you observe, like if you have multiple number of messages if you are transmitting, then if you observe there, you have serial to parallel converter at the transmitter section. So initially the series data will be converted into parallel information. Series to parallel converter is there. So that's why you can use a single column matrix consisting of m number of rows and 1 column. And at the receiver side, you will have parallel to series converter. This is of size 1 by n. Okay. Now, if you multiply these two, you will get a matrix of size m by n, where m represents the number of rows and n represents the number of columns. And m also represents the events present in the transmitter side, and n represents the number of events present on the receiver side. So what is the matrix size of joint probability? Joint probability matrix is of size m by n, where m represents the number of events on the transmitter and n represents the number of events on the receiver side. And x1, what is the first element? X1, y1 and second element is x1, y2. In the row I am speaking. X1, y1, x1, y2 up to so on x1, yn. And second row is x2, y1, x2, y2 up to so on x2, yn. And up to so on, how many rows? M rows. So xm, y1, xm, y2 up to so on xm, yn. And number of rows and number of columns and m number of rows. So what is the joint probability? P of xj of the transmitter. And what is the marginal probability of transmitter? P of xj. What is the marginal probability of receiver? P of yk, or you can also represent it as P of capital Y or P of capital X. So joint probability P of x comma y is summation j is equal to 1 to m, summation k is equal to 1 to n, P of xj comma yk. So this matrix is of size m by n. So we have m number of rows and n number of columns. And if you see the probability matrix of the transmitter side, it is of size m by 1. M elements on the transmitter side. And if you see the probability matrix of receiver, it is of size 1 by n number of events for the receiver. Okay, please remember the matrix sizes so that it's useful for the problems. So matrix size of P of xj is m by 1 and matrix size of receiver is 1 by n, and joint probability matrix is of size m by n. So the matrix size is very much necessary while doing the problems. So please remember the matrix size of transmitter as m by 1, matrix size of receiver as 1 by n, and matrix size of joint probability as m by n. Okay, please remember. Now, let us define the expression for joint entropy. So what is the expression for joint entropy? Now, let us represent the expression for joint entropy as capital H of capital X comma capital Y, or in some other sense, in some other textbooks it will be given like, in simplified form it is written as H of XY, H of capital X comma capital Y, or H of XY. It is the joint entropy due to combined events relation, that occur for the transmitter section capital X, as X suffix small j number of events are there. J ranges from 1 to m. So x1 to xm అని రాసుకున్నారు. And for receiver section capital Y, it consists of k events. So y1 to yn, k ranges from 1 to n, with the joint probability p of xj comma yk. Now, our joint entropy is represented in terms of joint probability p of xj comma yk, having a matrix size of m by n. So, how can you represent the joint entropy? H of xy is equal to, why you considered two summations? Because you are considering the events of both the transmitter section and the receiver section. Transmitter section events range from j is equal to 1 to m, and the receiver section events range from k is equal to 1 to n. So minus summation j is equal to 1 to m, summation k is equal to 1 to n, p of xj comma yk multiplied by log p of xj comma yk base 2. Okay, so this is the general representation of joint entropy in terms of joint probability matrix. I request the students to please remember that to calculate the joint entropy. So ఇంతవరకు మీరు ఏం చేశారు? Entropy calculate చేశారు. How? Based on the number of events present in the given question. So మీకు ఇప్పుడు like 6 number of events ఇచ్చారు అనుకోండి, ఏం చేశారు? m is equal to 1 to 6 pj log pj base 2 అని చెప్పారు. బట్ ఇక్కడ మనం ఏం చెప్తున్నాం? ది జాయింట్ ఎంట్రోపీ అలానే కండిషన్ ఎంట్రోపీ, all these comes into existence only when we have more than one section. Whenever we speak about the communication system, it will have two sections. One is the transmitter section and other is the receiver section. Okay, so this is a reason like this joint entropy relies on the joint probability. Okay, the joint probability is constructed based on the joint like the marginal probability of transmitter p of xj and marginal probability of the receiver section. So marginal term represents the events of a particular section. Ante edo oka section ki either the transmitter or receiver. Marginal ante one particular section, but joint entropy ante it is a combined events relation for both the transmitter and receiver. అలానే మీరు కండిషనల్ ఎంట్రోపీ తీసుకున్నా, జాయింట్ ఎంట్రోపీ తీసుకున్నా, ఆల్ దీస్ ఆర్ లైక్ combined relation. This gives like interrelation between the transmitter section and receiver section, provides you the joint entropy and conditional entropies. Okay, so what is h of x comma y? H of x comma y represents the joint entropy. It is represented as minus summation j is equal to 1 to m, summation k is equal to 1 to n, p of xj comma yk log p of xj comma yk base 2, where p of xj comma yk is the joint probability matrix consisting of m number of rows and n number of columns. It is a matrix of size m by n. Okay. And what is the relation between marginal probability and p of xj and joint probability p of xj comma yk? Already I told you the relation. P of xj is equal to summation P of xj, please wait. P of xj is equal to summation k is equal to 1 to n P of xj comma yk. So whenever you replace the receiver section events in the joint probability, you will get P of xj. And similarly, if you replace or rewrite the events of transmitter section, you will get the receiver section marginal probability. Okay, P of yk is summation j is equal to 1 to m P of xj comma yk. So alane P of xj is summation k is equal to 1 to n P of xj comma yk. Now I think you are thorough with the expressions of marginal entropy of transmitter, marginal entropy of receiver, joint entropy of the communication system, which combines the transmitter and receiver section. So in order to calculate the marginal entropy of transmitter, you need the probability matrix of transmitter section. In order to calculate the marginal entropy of receiver, you need the probability matrix of receiver. Okay. So in order to calculate the joint entropy, you need the joint probability matrix P of xj comma yk. Okay, until and unless you don't know these probability matrix, you cannot calculate the corresponding kind of entropies. Okay, next let us move to the conditional entropy. Let us move to the concept of conditional entropy. Listen carefully. Here, how we have represented the joint entropy, capital H of x comma y, and how we represented the marginal entropies, H of x and H of y. And coming to the conditional entropy, it is of two types. One is H of x by y and second one is H of y by x. So for the whole communication system, we'll define five kinds of entropies. One is marginal entropy of transmitter, second one is marginal entropy of receiver, third is joint entropy. Okay, that is a combined relation between the transmitter and receiver, and fourth is conditional entropy of transmitter section knowing the receiver events, that is H of x by y, and conditional entropy of receiver section, that is H of y divided by x, represents the conditional entropy of receiver knowing the events of transmitter section. So total of 5 entropies you will study. So conditional entropies are of two types. One is H of x by y and other is H of y by x. Now let us move to the concept of conditional entropy of transmitter section knowing the events of receiver. Okay. Now let us move to the calculation of H of x by y. This H of x by y represents the conditional entropy that evaluates the parameters of transmitter, So what are the parameters of transmitter? x1, x2 up to so on xm. Okay, for j ranges from 1 to m. By knowing the receiver parameters, capital Y, that is y1, y2, y3 up to so on yn. For yk, k ranges from 1 to n parameters. Okay, so what is H of x by y? H of x by y represents the conditional entropy of transmitter section knowing the parameters of receiver. Okay, so that is H of x by y. And similarly, we have H of y by x. That is the conditional entropy of receiver knowing the transmitter parameters. Okay. Now I request the students to please listen carefully, because here we are deriving the expression for conditional entropy of transmitter knowing the receiver section parameters, that is H of x by y. Okay, listen carefully. So the first step for calculation for this derivation is, first step is represent the conditional entropy. So what is the conditional entropy? H of x by y. Please represent this conditional entropy H of x by y in terms of average conditional entropy H of x by yk at kth event of y. So what is average conditional entropy? H of x by yk at kth event of y. Please listen carefully. This conditional entropy H of x by y, first step is to represent conditional entropy in terms of average conditional entropy, knowing the kth event of y. అంటే yk తెలుసు మీకు. Only yk is known to you. Out of all the receiver parameters, only ykth event is known to you. Okay. And for example, that kth event is known to you. So H of x by y, first step is represent the conditional entropy H of x by y in terms of average conditional entropy H of x by yk. So yk is known to you. Then H of x by y, you can define it as summation k is equal to 1 to n p of yk into H of x by yk. Because H of yk is the conditional entropy of transmitter section, all transmitter section events. అందుకని capital X పెట్టారు. Divided by knowing ykth event. So k events తెలుసు, but all transmitter events you need to calculate. So here we are writing overall conditional entropy in terms of average conditional entropy H of x by yk. So average conditional entropy of all elements of receiver ante summation k is equal to 1 to n p of yk into the corresponding average conditional entropy ante H of capital X by yk. Here you should note that here you should note that p of capital X by yk. So in general, the meaning of probability of capital X by yk, what is the meaning of that? Probability of capital X అంటే మళ్ళీ ఎన్ని ఎలిమెంట్స్ ఉంటాయి? x1, x2, x3, x4 అలా xm వరకు ఉంటాయి. Knowing the kth of y. So p of capital X by yk is the probability of x1 by yk, x2 by yk, up to so on xm by yk. So this you can write it as summation j is equal to 1 to m p of xj by yk, p of xj by yk. So average conditional entropy H of x by yk, knowing only yk event is defined as H of x by yk. Okay, H of x by yk. So what is the first step in this? Conditional entropy H of x by y is represented in terms of H of x by yk. So take that equation 1, represent chestar. Next, second step into average conditional entropy H of x by yk. Okay, knowing only yk event is defined as, so this H of x by yk is defined as minus summation j is equal to 1 to m p of xj by yk log p of xj by yk base 2. Okay, this average conditional entropy kada manam define chestunnaru. So and the corresponding entropy is defined as knowing the corresponding probability. So minus summation, our x range from j is equal to 1 to m. Because only yk is known to you. In y, you know only one element, that is yk. And all elements of x we are calculating. So summation minus summation j is equal to 1 to n p log p base 2. P is p of xj by yk multiplied by log p of xj by yk base 2. Please consider this as equation 2. So now I think you can observe equation 1 and equation 2 clearly. What equation 1 represents? Equation 1 represents the conditional entropy h of x by y in terms of average conditional entropy h of x by yk as summation k is equal to 1 to n p of yk into h of x by yk and represent చేస్తారు. Good. Second step is represent this average conditional entropy, okay, or write down the expression for average conditional entropy knowing ykth event. So h of capital X by yk is x range from j1 to m. So the corresponding probability is p of xj by yk log p of xj by yk base 2. Now please observe equations 1 and 2. And from equation 2 you have h of x by yk value. Please substitute it in equation 1. Okay, please substitute it in equation 1. So please substitute h of x by yk expression from equation 2 in equation 1. Then you will get overall conditional entropy h of transmitter section knowing all the elements of capital Y, that is capital H of capital X by capital Y. It is equal to minus summation j is equal to 1 to m, summation k is equal to 1 to n, p of yk, as usual p of yk only, into just we are substituting h of x by yk in the expression of h of y. So already you have minus summation k is equal to 1 to, summation k is equal to 1 to n undi, but if you observe h of x by yk, you have minus summation j is equal to 1 to m. So please substitute 2 in 1. So ఏంటవుతుంది అప్పుడు మీకు p of yk into p of xj by yk into log p of xj by yk base 2. Okay. Please substitute equation 2 in equation 1. Then you will get it as minus summation j is equal to 1 to m, summation k is equal to 1 to n, p of yk into p of xj by yk into log p of xj by yk base 2. Just we substituted equation 2 in equation 1. మీరు ఏం చేశారు, we considered two steps. A step is a representation of conditional entropy in terms of capital H of x by y in terms of average conditional entropy knowing the value of yk. And next in this, as a step 2, we define the expression for h of x by yk as minus summation j is equal to 1 to n, 1 to m, p of xj by yk log p of xj by yk base 2. Next we substituted equation 2 in equation 1. Then we'll get this expression. Minus summation j is equal to 1 to m, summation k is equal to 1 to n, p of yk into p of xj by yk log p of xj by yk base 2. Now, and another thing is, coming to the whole chapter, you need to remember the Bayes theorem. So Bayes theorem states that, what Bayes theorem represents? Bayes theorem in the probability theory represent the relation between the marginal probabilities, conditional probability and joint probability. So if you observe the equation here, this Bayes theorem represents the relation between the marginal probabilities, in this case of communication system. In this example, the marginal probabilities are, for the transmitter it is p of xj and marginal probability of receiver is p of yk. Joint probability is p of xj comma yk. Probability is p of xj by yk. This is the conditional probability of transmitter knowing the receiver events. And p of yk by xj is the conditional probability of the receiver section events, or you can say that the calculation of probabilities of receiver section events knowing the transmitter section event. So in the denominator you have, if you see it as xj, you know the denominator section. Yk by xj undanukondi, you know the xj information. And if that conditional probability is p of xj by yk, you are solving the probability of xj knowing the receiver event yk. Okay, so what this Bayes theorem states? Bayes theorem states the interrelation between the two kinds of marginal probabilities, two kinds of conditional probabilities, and joint probability as P of xj comma yk is equal to P of xj into P of yk by xj, or it is P of yk into P of xj by yk. What is Bayes theorem? P of xj comma yk is either P of yk into P of xj by yk or P of xj into P of yk by xj. This is the Bayes theorem. Now here in this expression, so you have replaced equation 2 in equation 1. If you observe here, P of yk multiplied by P of xj by yk, you can replace this P of yk into P of xj by yk as P of xj comma yk. You can replace it as P of xj comma yk. So this is from the Bayes theorem. So you are replacing P of yk into P of xj by yk as P of xj comma yk. Now let us replacing the P of yk into P of xj by yk as joint probability. That is P of xj comma yk. Then the conditional entropy of transmitter section capital X, knowing the receiver section events capital Y, is defined as minus summation j is equal to 1 to m, summation k is equal to 1 to n. We have replaced P of yk into P of xj by yk as P of xj comma yk. So we have, okay, sorry. So what we are doing here, we have replaced P of yk into P of xj by yk as P of xj comma yk. Now you can see that minus summation j is equal to 1 to m, summation k is equal to 1 to n, P of xj comma yk into log P of xj by yk base 2. So it is minus summations P of xj comma yk is the joint probability matrix into log, here you have the corresponding conditional probability matrix and P of xj by yk base 2. So if you observe the expression for conditional entropy, so like if you observe the equations for marginal entropies, if you know the corresponding probability matrix, you can calculate the respective entropy. So if marginal entropy kavali and of transmitter kavali ante P of xj teliste sarpotundi. And if you want h of y, that marginal probability of receiver teliste sarpotundi. Endukani minus summation k is equal to 1 to n, P of yk log P of yk base 2 is the h of y. So similarly, if you know the P of xj comma yk, and if you know the joint probability matrix, then you can calculate the joint entropy. So joint entropy is defined as minus summation j is equal to 1 to m, summation k is equal to 1 to n, P of xj comma yk log P of xj comma yk base 2. But in the case of conditional entropy, in order to calculate conditional entropy, you need two types of probability matrices. అంటే మీకు రెండు probability matrices తెలియాలి. One is joint probability matrix and second one is the corresponding conditional probability matrix. Because if you observe the expression of h of x by y, inside the logarithm you should use the corresponding probability matrix. అంటే P of, ఇప్పుడు మీకు h of x by y కావాలి అంటే P of xj by yk. For example, if you need P of y by x, then you can use h of yk by xj. But outside the logarithm, you are using the joint probability matrix. Outside the logarithm, you will use joint probability matrix. So in order to solve the conditional entropy, you need the joint probability matrix, you need the help of joint probability matrix and the corresponding conditional probability matrix. So for example, if j is equal to 1 and k is equal to 1, so first element of joint probability matrix is considered here, and inside the logarithm first element of condition, the corresponding conditional probability matrix should be considered. Okay, so like that you need to, so you need two different probability matrices. Okay, this is about the first kind of conditional entropy. Okay, so make use of the same procedure to calculate the conditional entropy of h of y by x. So this is a second kind of conditional entropy. So what is h of y by x? So two kinds of conditional entropies are there here. One is h of x by y and h of y by x. H of x by y represents the conditional entropy of transmitter knowing the receiver section events, and h of y by x represents the conditional entropy of receiver knowing the transmitter section events. Okay, so this conditional entropy evaluates the parameters of receiver section and take capital Y, where Y consists of k number of events, where y1 to yn. Okay, this conditional entropy evaluates the parameters of receiver knowing the transmitter section events. So transmitter section events are x1, x2 up to so on xm for j ranges from 1 to m. So make use of same procedure. Instead of x, you please replace y, and instead of y, you please replace x. So same two steps you follow. First step is conditional entropy, represent the corresponding conditional entropy in terms of average conditional entropy knowing the xjth event. Sorry, this is jth event actually. This is the jth event. Jth event of x, you know. Okay. And using that, first thing is you use the same procedure. Okay. So what is the first step? Represent the conditional entropy in terms of average conditional entropy, that is h of y by xj, as h of y by x is minus summation j is equal to 1 to m p of xj into h of y by xj. Okay. What is the next step? Next, please replace h of y by xj as minus summation k is equal to 1 to n p of yk by xj into log p of yk by xj base 2. Okay, please replace this h of y by xj in the equation 1. So replace chesin tarvata, then make use of Bayes theorem. Okay, follow the same procedure. Make use of Bayes theorem. So in order to replace p of xj into p of yk by xj as p of xj comma yk. So because Bayes theorem relates the marginal probabilities, conditional probabilities and joint probability, then you will get h of y by x as minus summation j is equal to 1 to m, summation k is equal to 1 to n, p of xj comma yk log p of yk by xj base 2. So if you observe the expression of conditional entropy, here you should note that you require two probability matrices. One is the joint probability matrix and the other is the corresponding conditional probability matrix. So joint probability matrix is represented as p of xj comma yk and conditional probability matrix is represented as p of yk by xj. So now I request any one of the student to please tell me the expressions of all the 5 different kinds of entropies. Any one of you kindly respond and tell me the expressions for the marginal entropy of transmitter, marginal entropy of receiver, joint entropy, alane conditional entropy of transmitter knowing receiver data and conditional entropy of receiver knowing the transmitter data. So I request any one of the student to please tell me the expressions for all the 5 kinds of entropies for the conditional, like for the general communication system. Any one of you kindly respond. C8, C8 ఉన్నరమ్మా C8 C8 roll number is there. C8 C9 C9.
Yes, ma'am.
Okay, ma. Can you please tell me the expressions for all the 5 kinds of entropies?
Yes, ma'am. Marginal entropy of a transmitter H of x equal to minus sigma j equal to 1 to m p of xj into log 2 of p of xj.
ఒకసారి వినండి. See, while pronouncing the log 2 అని చెప్పొద్దు first. Log p of xj base 2. Okay, this is base. Okay, ma?
Okay, ma'am.
Okay. And one more thing is this p of, what is p of xj? P of xj is the probability matrix of the events of transmitter section. Okay. Is it okay? మా ఉన్నారా? C9.
Yes, ma'am. Signal సరిగ్గా లేదు మ్యామ్ ఇక్కడ.
Okay, no problem. So P of xj is the probability matrix of all the events of transmitter section. Okay. What is the matrix size of P of xj? H1. H1. I0. I0. Please respond. I0.
Yes, ma'am.
Okay, ma. Can you tell me the expressions for all the entropies what we discussed now? H2.
Ma'am.
Okay. So can you tell me the expressions for all the different kinds of entropies and the matrix size of the respective probability matrices?
Okay, ma'am. So marginal entropy of transmitter X is H of X is equal to minus summation J is equal to 1 to capital M P of Xj log P of Xj to the base 2.
Okay. What is the matrix size of P of xj?
P of Xj.
So I will go to the respective slide. You see and tell me. What is the matrix size of P of xj?
M into N.
M by 1 or N?
Okay, M by 1, ma'am.
M by 1. P of xj probability matrix size is M by 1. Alane P of yk matrix size is
1 by N.
1 by N. P of xj comma yk matrix size is
M by N.
M by N. Okay. Please continue with the other kinds of entropies.
Okay, ma'am. Next, marginal entropy of receiver y is h of y is equal to minus summation k is equal to 1 to n p of yk log p of yk to the base 2.
Okay.
Next, joint entropy is h of x comma y is equal to minus summation j is equal to 1 to m k is equal to 1 to n p of xj yk log p of xj yk to the base 2.
Okay. What is P of xj yk?
Joint probability.
Joint probability matrix. Okay. Next, can you please tell me the expression for conditional entropy of transmitter knowing the receiver data?
Okay, ma'am. It's h of x by y is equal to minus summation j is equal to 1 to n summation k is equal to 1 to n p of xj yk log p of xj by yk base 2.
Okay. Okay. So what is P of xj by yk? It is the corresponding conditional probability matrix. So in order to calculate the conditional entropy, you need the joint probability matrix as well as the conditional probability matrix, the corresponding conditional probability matrix. Okay. So similarly, tell me the expression for conditional entropy of receiver knowing the transmitter data.
H of y by x is equal to minus summation j is equal to 1 to m summation k is equal to 1 to n p of xj yk log p of yk by xj to the base 2.
Okay, okay. Thank you, Ma. Very good. Thank you. Please wait. I will take the attendance and then you can leave. So, any doubts? So, if you have any doubts, you can ask or else you can leave. Session is over.